When ionic compounds are added to water, two competing forces come into play. The attractive forces between the oppositely charged ions making up the solid. So for instance, if you had Na and Cl for sodium chloride, and the attractive force between the water and the ions, we're going to see that water is attracted to these ions. Water is a polar molecule, which means it has a positive side and a negative side. This is the negative side, and these are the positive side. So you can imagine that this positive side might be attracted to the negative ions, and this negative side might be attracted to the positive ions. The force of attraction between water and the ions tends to bring the solid into solution. The ions separated and are surrounded by the water molecules. If this force of attraction is the stronger one, then the ionic compound dissolves. The force of attraction between the oppositely charged ions tends to keep them in the solid state together. Their solubility in water is low. So if the water molecules are able to separate the ions, they dissolve. If the force of attraction between the ions is stronger, then they stay together. And that's when you see a precipitate at the bottom of a beaker. They stay together as a solid. In this diagram here, you can imagine water molecules pulling ions out of the crystal structure and then surrounding them. This process is called dissolution or dissolving. Dissolving is fine. So you can see this water molecule here comes in with the positive side facing in. It's going to try to pull this negative ion out of there. Okay? So some ionic compounds are very soluble in water and others are not. Unfortunately, there's really no good way to predict which compounds will be soluble and which will not. That's why we use a table of solubility rules. We would like you to memorize a very, very small portion of that table because a working knowledge of solubility rules is going to make everything a bit easier to do. We call these the super solubility rules. Okay? All ionic compounds containing the nitrate ion will be soluble. Okay? So we say all nitrates are soluble. All ionic compounds containing an alkali metal ion are soluble. So we say all alkali metals are soluble, but really we mean compounds with the ions. So for instance, lithium nitrate is certainly going to be soluble, okay, because it has both lithium and nitrate, but it only needs one of them, okay? So any nitrate, right, silver nitrate, we're going to discover silver doesn't like to dissolve at all, but it does with silver, with nitrate, so silver nitrate would be soluble. All ionic compounds containing the ammonium ion are soluble. So anything with NH4 plus in it is also going to be soluble. All acetate ion compounds are soluble, except there's that one exception. Okay? So the one exception to acetate is that silver acetate is insoluble, and the one exception to silver is that silver nitrate is soluble. So silver ion is almost always insoluble. There's only one time when it's not. And acetate is always soluble. There's only one example when it's not. And all acids are soluble. So nitric acid, sulfuric acid, all the acids are going to be soluble. Okay. Of course, there's a much more comprehensive list of solubility rules, including one on page 75 of your textbook. So you can find it on page 75 as a reference. Okay. We will also, we'll give you a longer one that you can use as a reference. So here's an example of a solubility rules chart. As you can imagine, trying to memorize all of this would be a huge chore. We don't need to spend a lot of time memorizing these rules because they're easy enough to look up. Okay, as long as we know our super solubility rules, we can look up the rest. It's also complicated further by the fact that some of the compounds are called slightly soluble. All these guys in this little peach color. So how do we classify them when we're trying to decide if a precipitate's going to form? Are they soluble or not soluble? Well, that's for a later chapter. So that's our conversation about the solubility of ionic compounds in water.